We're on problem 116. What is the value of a plus b squared? Statement 1. Statement 1 tells us that a times b is equal to 0. That to me seems fairly useless. Let me see. What if we expand that out? That's equal to a squared plus 2ab plus b squared, right? This is the same thing. I just expanded out a plus b squared. And so they're giving us a piece. They're telling us that this right here, this term right here is going to be equal to 0, right? If ab is equal to 0, this term right here is going to be equal to 0. But we still don't know what a squared and b squared are. So statement 1 by itself, not so useful. Statement 2, a minus b squared is equal to 36. This is interesting. So let's expand this out a little bit. So this tells us, so you might want to say, oh, that means that a minus b is plus or minus 6. But actually, I don't think that is going to help you as much. Well, actually, that could help you as well. But the way I'm thinking about it is, let's expand this out. We get a squared minus 2ab minus 2ab plus b squared, right, is equal to 36. So by itself, this statement isn't that useful. I mean, even here, this statement says that if you were to take the square root of both sides, it tells us that the difference between a and b is either positive 6 or negative 6 if you took the square root of both sides. So statement 2 by itself is kind of useless. But if you use them together, you expand out statement 2, you get this. Now, if we also take in statement 1 and we say, oh, ab is equal to 0, so then that is equal to 0. And we're left with a squared plus b squared is equal to 36. And if a squared plus b squared is equal to 36, then we know that this a squared and plus b squared is also equal to 36, right? So that tells us that a plus b squared is equal to 36 as well. So both statements together are sufficient. And this is interesting because if you think about it, it makes a lot of sense. This statement tells us that the difference between a and b, and this is all a waste of time, but I just want to give you some intuition. This tells us that a minus b is equal to plus or minus 6, right? So it tells you that the difference between a and b is either positive 6 or minus 6, or that one is 6 bigger than the other, but we don't know which way it goes. This statement tells us that one of them is equal to 0, right? Both of them aren't going to be equal to 0 because there's a 6 difference, right? So one of them, if one of them is equal to 0, then the other one is either going to be plus or minus 6, right? And if we look at here, if we look at this statement, one of these numbers is 0, the other one is plus or minus 6, but it doesn't matter. If one is 0 and one is plus 6, then you square it, you get 36. If one is 0 and the other is not minus 6, you square it, you get 36. So anyway, just wanted to give you that little intuition, but the correct answer is that both statements together are necessary to solve this problem. 117. The more connections you can make while you're doing these math problems, the better you'll be. Really better off you'll be in life, I think. It'll all start making sense. All right, they've drawn this thing. This. Okay. And then they draw this down like that. And let's see, this is L, M, N, and K. In the figure above, what is the ratio of Kn to Mn? So they want to know the ratio of this side, Kn to Mn. Kn to Mn. Fair enough. Okay, statement number 1 tells us the perimeter of rectangle KLMN. The perimeter of rectangle KLMN is 30 meters. So perimeter is equal to 30 meters. So this is a rectangle, right? So what does this tell? That tells us that, let's put it in terms of the things we care about. That 2 times mn, right? Because mn and kl are going to be the same length since it's a rectangle. So this tells us that 2 times mn plus 2 times kn, because kn and lm are the same length, so let's just put it in the terms of the things we care about, plus 2 times kn, plus 2 times kn is equal to 30. That's the perimeter. Twice this plus twice this is the perimeter. You could say that plus that plus that plus that, but this keeps it in terms of that. So, what I think we can let's divide both sides by 2. You get mn plus kn is equal to 30. And actually, yeah, you still can't figure out the ratio between the two. You just know that the sum of the two are equal to 30. Let's look at statement 2. Right, you can't figure out the ratio from this. Statement 2 tells us the 3 small rectangles have the same dimensions. The 3 small rectangles have the same dimensions. This is interesting. So that's telling us, well, that's interesting, because that tells us that that tells us that this distance and this distance have to be the same. That tells us that, and if this distance and this distance are the same, then this distance right there is twice this distance. How did I get that? Well, this distance is twice each of these distances, right? This longer side of this horizontal rectangle is twice this, and this is the same thing as this. So for all of these rectangles, the ratio of their sides is 1 to 2 is the ratio of the sides. So let's create a unit called the short side of this rectangle, right? So how many units long is mn? Well, mn is going to be, this side right here is going to be 2 of those units long. So 1, 2, and then 3, right? And we figured that out because the long side of this is twice as long as the short side. So if we were measuring these in terms of the short sides of the rectangle, mn is 3 of them, and then kn is 2 of them. 1, 2, right? 1, 2. So the ratio of kn to mn, it doesn't matter what units you measure in, you just want to get the ratio. So the ratio is going to be equal to 2 to 3. So statement 2 alone is sufficient to solve this problem. Next question. 118. If n is a positive integer, is 150 over n an integer? So that's essentially asking us, is n divisible into 150? That's the only way that 150 over n is going to be an integer. Statement number 1 tells us that n is less than 7. Now, if every number less than 7 is divisible into 150, then we're all set, because we know it's positive as well. We know it's positive. So, and 1 works, right? 2 works, 75. 3 works, 50. 4, let's see, you go 4 into, 4 goes into 100, and then does it go into 50? 4 goes into 50. No, it doesn't go into 50. So 4 does not work. So just by telling us that n is less than 7 does not solve the problem, because if n was 4, 4 does not go into 150 evenly. It goes into it, well, I'm not going to figure it out. 4 goes into it, what, 9? It goes into 25, 25 plus 12, 37.5 times, so that doesn't do us any good. So statement 1 by itself isn't that useful. Statement 2, n is a prime number. N is prime. So this statement by itself is not useful because, n could be a prime number larger than 150. So that by itself doesn't tell us that we definitely can get an integer. And n could easily be 1, or it could be 3, which would allow it. So n doesn't tell you one way or another whether this is an integer. But if you combine the two statements, if you say that n is a prime number that has to be less than 7, then we can take 4 out of the picture, because 4 isn't prime. And then you put 5 there. 5 definitely does go into 150. And then 6 does go into 150. It goes into 120, and then you have 30 left over, so 6 goes into 120. So all of the prime numbers less than 7 are divisible into 150. So both statements combined are sufficient to answer this question. See you in the next video.